Now let's return to the voting for captain problem and solve it. So as mentioned earlier, we divide the solution for this problem into three phases. So in the first phase, we'll count how many votes are received by each player. Then after that, we sort of divide the remaining task into two phases. The first one is we scan through all the votes, and then we keep track of some information from this scanning. And then the last phase is we're going to decide which of the four outcome is it, so what to print, and then print that information. So the last phase goal is to print the information. And the second phase is to collect enough information so that we know which of the four outcome is it. The question is what information should we keep track of? So before we move on, I encourage you to think about this. The question is what information, how many variables, what are they, what information you want in order to be able to tell which of the four outcome is it, and then start the printing process for that. So I assume you have thought about this. There is no single right answer. So there are different ways of doing it. There are many correct ways of doing it. The difference is maybe some way are a little bit more elegant than others. It's simpler, and the code is cleaner than others. So what I ended up deciding to do is to keep track of three pieces of information. First is the max number of votes received by any player. So this is needed in order to determine whether that is a majority or not. And the second is the number of players who receive that max vote. And we're going to see why I choose to do that, to keep track of that information. And I also keep track of the second highest number of votes. So again, this is because one of the outcomes require to printing some information. So there are other ways to do it, but I ended up choosing to keep track of these three variables by scanning through the votes. So here is the part 2 code to compute that three pieces of information. Max V is the highest number of votes. Max C is the number of players who received the max V number of votes. And then I also maintain the second highest number of votes here. So the logic is quite standard. The red part are the ones I want to highlight. So this is also kind of commonly used idiom to keep track of the number of something, to have that. So each time if we see the player I, if player's I's vote is bigger than the max we've seen so far, then the second max will become max. So we've seen that before. Now the max V will be assigned this player I's number of votes, because now we have a new max value, and so the max C should be 1, because we have exactly one player at this point who have a max V number of votes. So if the current player's vote is equal the max V, then we will increment this. So this is a part that I think I don't think we've used before in the example problem, because I don't recall we actually keep track of the number of so we sort of just keep track of the max or maybe the second max, but this is we increment the number of counters. So So the next part is slightly different from what we did in the previous example problem. We need to update the second max, right? So at this point we know the current player's vote is less than max V, but it could still be bigger than second max V. So what we did before was if count I greater than second max V, second max V equals count I. So that can be equivalented, represented using the function max. So max will basically take two values and return the bigger of them. So this is a function defined in the standard library, so we can use that directly. So just to recap, we can use the max, and similarly there's a min. So this is equivalent to this this way of writing it that we've done before. So in fact, the max and min are defined using template. So they can take not just integer, but many other type. So long as there's a comparison operator is supported, then we can do max. Okay, so after we collecting that 3 pieces of information, how do we decide which of the 4 outcome is it? So this slide lists the 4 outcomes. So there we have co-captains, and we have only one single captain, and no player receive majority, and also only one player receive any vote but less than majority. So think about if you use the 3 variables that we computed from the previous slide, what will be the condition for each of the 4 outcomes? And also for this case, no player receive majority. We need to find out the smallest group of 2 or more players, so that this will be go to the next round. Maybe we will vote. Maybe they will vote again. Or so how do we determine that? So this is how I did it. So the majority can be computed using this maxv greater than equal to n plus 1 divided by 2. So this, if n is even, then n plus 1 divided by 2 will be exactly the same as n divided by 2, because we always round down. If n is odd, then this will require sort of more than half. So if n is 5, this will come out to be 3, which is what we want, because 2 will not be majority when we have 5 players. And the co-captain will be that happens, but we also have maxv equals 2. And then single captain will be that happens, and maxv equals 1. So essentially we have a captain if maxv is greater than this. Then if that doesn't happen, then we will have we will have the maxv less than the majority. Here there are 2 cases. So the 4 is the more specialized case, which can be used by checking max C is 1. So that means there's a single user who received the highest number of votes. And then second max V is 0. So that means that no one received a vote other than 0. Only one person received any positive vote. So that can be expressed using the condition on the bottom of the slides. And then 3 will be the last case. So we don't have majority and we don't have the 4 being true, then we are end up in this case. Here there are different ways of deciding how to choose the player to advance to the next round. So my approach is to use a threshold and select all the player with vote higher than the threshold. Then the threshold value will be either max V or second max V. It will max V if max is greater than 1. So if we have more than 1 player who received the most number of votes, then we'll just take that group. If there's a single player receive the max number of votes, then we will need to use the second max V. So that's why I keep track of second max V. And as you can see, max C is used in several of these conditions. So this is the part 3 code for voting captains. So the first if part is when there is a captain. So when there is a captain, I need to figure out who is the captain. So in fact, I could sort of move this logic to second phase to also figure out the individual with the highest number of votes. However, that individual, there may be more than one of them. So the logic is a little bit a little bit more complicated in my view. So I chose to do it here. So once I know there's a captain, but there may be 1 or 2 captains. So the way I did it, I declared an array of size 2, and then I also sort of use an index into this array. So then I will scan through all the vote count. If any player's vote equals max V, then that is one of our captains. So I will store that player's ID into this caps, start with cap 0, and then after I storing this numCap will increase by 1. So the next time when I see the second one, this will become this will be caps 1. So when this condition is satisfied, it's guaranteed that there can be at most 2 players who received at least half of the vote. So this will not index auto bound will not occur. So we will not execute this part more than 2 times. So then after that, I simply print based on how many captain are there. So at this point, in fact, numCap should equal to maxc. So I can use numCap to check, or I can use maxc to check. It's the same. So then this is the last outcome. So the low voting count, which is determined by the condition there's no second vote and the maxc is 1. So other than that, we are in the third case. So we need to, I will choose a threshold based on whether maxc. So this is the syntax that I want to introduce on the next slide. It's a conditional expression, but essentially threshold will be maxv if maxc is greater than 1. So if there's more than 1 player receive the maxv number of votes, then that's the threshold we want. Otherwise, we use the second maxv. So after we set the threshold, then we just scan through this again, and any candidate, any player who's received the vote at least the threshold, we will output that player's ID. So, and in the end, we output the period, because that's what's required by the problem specification. So yeah, let's examine this syntax. This is known as a conditional expression. So this conditional expression will evaluate to maxv if this part that's before the question mark is true, and evaluate to the second part if this part evaluate to false. So more generally, a conditional expression take the form of, you have 3 expressions separated by a question mark and a colon. So expression 1, question mark, expression 2, colon, expression 3. So expression 1 will be interpreted as a Boolean expression. Of course, it could, as we discussed earlier, it actually could be a number. So long as it's non-zero, it will be interpreted as true. So if expression 1 is true, the result will be expression 2's value. Otherwise, the result will be expression 3's value. So that's what we want here. So the final thing about using numerical values as Boolean values. So in C++ and C, numerical value can also be used as Boolean value. So this is, I guess, it makes some code easier to write, but it's can be dangerous. So it's easier to. It's also easy to result in buggy code that are difficult to find out what is the bug. So Java does not have this feature. In Java, Boolean type is only true or false. You cannot use a numerical value for a Boolean type, which is better. But this is C allowed this, and C++ inherited this design feature. So to try to drive home this lesson, I want you to predict what will happen with this code. So we have int a assigned to 0, and the intention is to compare whether if a is negative 1, we will output yes. Otherwise, we will output no. But unfortunately, while we type this, instead of double equal, we just had a single equal here. So this is a very common bug. So I saw that from submissions to week 1, and I distinctly remember that I had a similar bug myself in the past, and it usually takes quite a bit of time of debugging to figure out what is the error. Because if you didn't notice this, you think this is a double equal, you wouldn't sort of see that. Then everything logically seems that your logic is correct, but the output is not what you believe should happen. So typically to result in, you need to print. For me, when I debug, I print many things, and then finally I narrow down which branches is executed, and then realize the condition is actually there's a typo there. So for this particular case, the output is yes, because it will actually go to this branch. The reason is this expression a equals -1 will also have a value, which is the -1. So -1 is assigned to a, and is also treated as the value of the whole expression. So assignment is the operator. A equals -1 is the expression. It has a value, and the value is -1. And -1 is not 0, so it's treated as true. So then this will be value to true. So we will print out yes. So just I guess first be careful when you write comparison operator. Don't ever use use assignment. In fact, I guess the other direction could also occur. You could intend to write a equals 1, and then you write a equal 1, and in which case no assignment happens. So that's the other way that could also be wrong.